Right. So the analytical geometry you have to go over on your own, right? Most of it is it's grade 10 work. The only new concept which is very important for you to know is the angle of inclination. You have to know that that's the only concept in grade 11. The angle of inclination. You have to know. Right. The rest, like the distance formula, midpoint, your knowledge of the properties of parts and so on, that's basic from grade 10. Right. So trigonometry is a major topic not only in this grade but in grade 12 as well. And for your paper it has got a lot of marks. Okay. So let's start with the Cartesian plane. Right. When you get a question like this, always remember, before you start answering, there are two ways. You can be given a diagram like this, or you can be given a trigonometric equation, and then you may be asked to use that equation to draw a diagram. But you have to remember that sine theta is equal to y over r, cos theta is x over r, and tan theta is y over x. So you have to remember that, right? And also, the theorem of Pythagoras, r squared equals x squared plus y squared. Okay, so you need to make sure that you are aware of that. Now, this is a very common question, okay, even in metric as well. So you have to know your trigonometric ratios on the Cartesian plane. Right, so this question here, you are given the diagram, they are given point P in the first quadrant. So the 1 is an x value, the 3 is a y value. Obviously, the terminal ray, that is the hypotenuse r, is not given. And the angle theta is an acute angle because the diagram is drawn in the first quadrant. So the first question says, make use of the diagram to calculate the value of theta. Okay? Now, I'm sure you are aware, as I said, that here we have got an x value, we have a y value, which means the trigonometric ratio that we can use is going to be tan, because x is given, y is given, r is not given. Okay, I want to encourage you to calculate the value of r so that you can use sine or cos. But if you can't see that you can use tan, then maybe you have to calculate the value of r. But it's not necessary. So, to calculate the value of theta, I'll write tan theta is equal to y over x. Remember, I'm going to calculate theta here. So tan theta is going to be equal to y, which is equal to 3, and x is 1. So what this means is that my equation becomes tan theta equal to 3. So theta is going to be shift tan of 3. What answer do you get? What is shift tan of 3? 71.57 degrees. So that's the value of that angle theta. Right? Are you following me? This is very straightforward. It's actually grade 10. Okay? Because the Cartesian plane is best taught in grade 10. So it's very straightforward. Then the next question now, you have to calculate r. Okay? So we're going to calculate the value of r and what? Are you okay? No, you don't have to take a picture. Okay. Alright. So to do the next question, it says calculate the length of OP, which is the value of r. So we are going to calculate that. Please be aware that the center here, that is represented by a capital letter O. So I'm doing 5.1 to 2. So we use the theorem of Pythagoras. But here I can write this as r squared is equal to OP squared. That's equal to x squared plus y squared. Okay? And here I can say OP squared. X, we know that is 1, and y is 3. So we get here 10. So OP squared is equal to 10. So r equals OP squared is 10. Now remember, OP is the same as r, and it's always positive. Okay? The length of this line here is always a positive answer. The value of r is always positive. It's never negative. Right? So I've done 5.1.2. Most of the questions on the Cartesian plane, you have to calculate the value of r or x or y, depending on the diagram and the information you will be given. Right? Then, once you do 5.1.2, you need to be aware that the next question now require you to apply those equations. Let me delete this question. Right? These equations are that I wrote there. So we now need to apply them after finding the value of r. So we're going to use probably those three and one of those three. Okay, so 5.1.3, it says determine the values of the following without using a calculator. Now, questions like this, you are not supposed to use a calculator. You have to show all your working out. Okay, don't skip any steps. So let's start with 5.1.3a. Right, sine theta, this one is very straightforward. You just write the formula, which is y over r, and then you substitute. The y is 3, the r is square root of 10. Now, we're only calculating ratios here. So there's no need to convert that 3 over square root of 10 to a decimal. You leave it like that. Okay? Well, if you want to rationalize it, you can, but it's not important. So if you rationalize this, you get 3 root of 10 over 10. But that's not important. You just have to stop here. Okay? You get your full marks because it's just 1 mark. If you decide to rationalize, you still get 1 mark, but it's not important. Any questions there? Right? Then, sometimes you might need to apply your knowledge of reduction formulae from grade 11. So far, everything I've done is grade 10 work. Everything I've done up to 5.1.3b. Now, 5.1.3b, because we have got 180 plus theta, that means we have to apply our knowledge of reductions. So you have to know your reduction formula. Okay, if you forgot, you haven't refreshed yourself, you have today and tomorrow to refresh yourself. Reduction formula, you have to know.
So the next step then is sin x equals negative cos x.
Yes. So we have 5.1.3b. Need to find the value of cos 180 degrees plus theta. Okay? Now you know that theta, when you're dealing with reduction, theta is considered as an acute angle. So 180 degrees plus theta is in the third quadrant. Therefore, the ratio for cos 180 plus theta must be a negative ratio. And this will be called minus cosine of theta. Okay? But we know that cosine of theta is equal to x over r. So I prefer to write this as minus x over r. Our x is 1 and our r is square root of 10. So the final answer will be minus 1 over square root of 10. And then you stop. Alright? Okay, just right. Yeah, sketch, yeah, that's all. For now. Sketch that. Right. We are taking a break. Let me hydrate a little bit. But you have to know how to sketch. Yeah, you have to know how to sketch. Huh?
Tissue, we have tissue.
I need a shot. I used to, but I don't think but also there's a button for girls. Yeah, unfortunately, I can't assist you. Please don't take too long. By 10 o'clock, we'll restart. Hmm.
And there's a question that I was thinking is do we have to find a general solution for like the values of x and something so you have to decrease the general solution
I talking about the question. The
In a
question.
trip graph. And then I think it's one of those questions that goes on these time. And then you are, oh, it's like where the interval. Yeah. So it's like where you define line.
Are you talking about question where it says f of x is greater than or equal to g of x? Those type of questions.
But then the one that's like where they intersect.
Where they intersect.
Yeah, where they touch and have to go.
Yeah, but you see, those type of questions now, you can get the point of intersection from by sketching. You can also get it by solving the equations. You see, like us here, we have already used the general solution, right? We have determined the general solution. We can use that general solution to determine the point of intersection. Yes, the general solution we found, it is related to this graph.
So like if we haven't found it, if we didn't like
If you didn't find it and you are given two graphs, then you have to determine it on your own. But that's a long method now, especially if you are given the graph.
whenever I do like we done this right before, and then when you're looking at the graph, I don't always get it right.
So is cos x plus 60 equal to cos 60?
Cos what?
X plus 60, is that equal to cos 60?
No.
Sine
No.
Oh, sine 30.
It's no. No.
Oh, it's 90.
Cos x plus 60, you have to, if you want to rewrite in terms of sine, it will be sine 90 degrees minus, in brackets, x plus 60.
But we don't have to rewrite it. We just put it.
No, you don't have to rewrite it. You don't have to rewrite it. But next year, when you do the compound identities, it's going to be much easier to understand. Okay, we are going to do a question like the one that you asked. I think it's one of the questions. I don't know, maybe it is the type of question that you're asking. But there are two ways of solving for x at the point of intersection. Either you use the sketched graphs or you use the general solution to find the point. Yeah, and then you estimate. But if you don't, if you don't have both graphs sketched, then the only way is to use the general solution. In fact, you can't separate trigonometric equations and trigonometric graphs. They are related. You know, putting the graph of time can make things very complicated. So generally, the graph of time is not tested most of the time.
What do you mean by for questions or for sketching?
For sketching, but for interpretation, yes.
Yes, because they like those questions.
Yeah, for your test, you have to know all the three graphs. All of them.
But the interval for this be 45.
No, it's going to be 90. But because of the step, the period is 360. So 360 divided by 4 gives you 90 degrees. But you can also use 45 because 45 is a factor of what? Of 90.
Why is the period 360?
Yeah, because the B value for that graph is a 1. So 360 divided by 1 gives you 360. So your period is going to be 360 over 4. So your step, you can make it 90 or you can make it. But I would suggest that, yeah, you can make it 90. If you're having challenges, then you can adjust it you can adjust the step to 30 degrees. Okay, the marks, if it's one graph, like in your paper, it's only one graph. So you can have mark for the shape of the graph, right? Then you can have the x-intercept and the y-intercept. So usually it's just 3 marks. It's not a lot of marks. But there are 3 easy marks. The what?
The coordinates, 6 out of the coordinates of the actual points of.
Okay, remember when you are sketching the graph, use the calculator, right? You must plot your points, indicate the plotting, then the joining of the points. So, no, there are no marks for plotting. You get a mark for the actual shape of the graph. Then your x-intercept, y-intercept.
So we don't have to write the coordinates like.
There are no marks for writing the coordinates on the graph. Unfortunately, there are no marks for that. I wonder why not learners they do it, but there's no mark allocated for. For the trigonometric graphs, there are no marks allocated for the coordinates. Right? No, I'm being honest with you. That's how it is. Okay, let me carry on. I can't wait for those two.
So we just wait our time
Do it now, quickly, and okay, I think I can try to squeeze it there. Yeah, I need to include negative 90. That's why I stopped. Hey, you too. Okay, so that's it there. All right. So if you sketch the graph, you get something like this. Right? So that's the sketching there. You need a bit of some background. Then use the graphs to determine the values of x. Now that part it can be done using the general solution. Right? For this question you could use the general solution, but there was no need. After sketching your graph 6.3.1, if f of x is greater than or equal to g of x, it means that the sine graph, which is f of x, you see this sine graph here, that's f of x. I'm sure you can see it there. So, right, this is f of x, the sine graph. Then g of x is the cos x. So if you see the question saying f of x is greater than or equal to g of x, it means f of x is above g of x. Okay? So which one is our f of x? Right? This one here. That's the f of x. So you can see that it looks like the one which is already sketched. So this is f of x. That's f of x. So I can put f there. That's f. The green one, that's g of x. So we need to determine values of x such that the sine graph, that is the black one, is above the green one. Right? So you can see that there is a point here. It's above, right? Above, up from minus 90 up to there, it's above. Then from here up to there, it's also above. Okay? Furthermore, from here up to minus 180, it's also above. Okay, now the point of intersection, now you might probably have to estimate it. Okay? You have to probably estimate, because if you are going to use the graphs, unless if you've got a grid which is perfect, but the one that I gave you in your paper, it's very nice. I can commend myself. You must tell me if you see me after the paper how I think. But it's a very nice grid. I made it very clear for you so that you can plot it nicely. Right, so we might have to approximate that. The good thing is, in my case, I've got a computer, right? So the computer can help me. Right, so I'll just go to intersection. Right, then I have to click the point of intersection. Right. That will help me to just identify those values. Okay, that's for me now with the computer. Okay. So point A, we have got minus 63 degrees. This is point A. It's minus what? 63. Okay, by the way, you can also download this graphing calculator if you want. It's called GeoGebra. You get it for free, right? GeoGebra graphing calculator. It's for free. There's a mobile version as well, if you like. And it can help you, but you probably might have to learn how it works as well. But if you have got a challenge, you can ask me, then I can assist you. Because you can do the algebraic graphs, that is straight line, parabola, hyperbola, exponential. You can also do the trigonometry graph. So you've got minus 63. It's called GeoGebra graphing calculator.
Another program for applying Sana.
Sine. Okay. So our first answer here, it's 2 marks, but I feel like it wasn't that fair. So this will be minus 90. Okay, let me use more clear. So the first answer will be minus 90 degrees is less than or equal to x is less than or equal to minus 63 degrees. That's the first answer. Okay. In your case, if you're using a grid, you might have a challenge to locate the exact value of x there. So we can give a room for error.
How big is the unit?
Well, we could say up to 10 degrees maximum, right? Then, right? Then for B, right, it's minus, so it's going to be positive 9 degrees. For C, it's going to be 57, right? So from 9 to 57. So the other answer, it will be between 9 degrees and 57 degrees. Now, there's a third solution to this. That's why I feel like the mark allocation was not fair. Right? The third solution, for point D is 177. Right? The question was saying sketch the graph between what? Between minus 90 and what? And 180 degrees. So there's a third solution. The third solution will be x is between 177 and 180 degrees. Alright? Yeah. So there are 3 solutions. I suspect that since it's 2 marks, if you wrote any 2 of those 3, then you get what? You get your 2 full marks. Are you following? F of x is greater than or equal to g of x means the graph of f is above the graph of g. That's what it means. Okay. Then 6.3.2 says f of x times g of x will give you a 0, or it will give you a positive answer. Okay? Now, f of x times g of x, for you to get a negative answer, it means that the y value for f of x is negative, the one for g of x is positive. Or the y value for f of x is positive, the one for g of x is negative. That's what it means. Are you following what I'm saying? Remember, f of x is y, g of x is also what? It's also y. Right? So if you look at the graph here, obviously, we can't look at the third quadrant. Okay? Okay, I'm just going to correct myself there. We can't look at where both graphs are in the third quadrant. One of them must be in the second graph or in the what? In the third. So if you look at from this point here up to there, okay? So we have got x equal to 0. Here, x is equal to a specific value there, which you have to estimate. Okay, you have to estimate that value. So the first interval is going to be between the x value here and 0 degrees. Okay? Are you following? So the good thing is, in my case, now I want you to be aware that in your case you won't have a computer, so you have to approximate. Right? In my case, I've got a computer, so all I can do is just go to the graph, right? And well, here I need the roots now. So the roots of what? Of both graphs, right? Okay? Do you understand what I mean by roots? Where y is 0. So for I, let me scroll down. This is not that easy to find, but you can substitute y equal to 0, then you solve. So it's minus 9 at this point here. It's minus 9, that's 0. So our first solution is going to be, there's a greater than or equal to, so it will be, sorry, less than or equal to be minus 9 degrees is less than or equal to x, and x is less than or equal to 0 degrees. Are you following that? Are you following? Look at the green graph is in the second quadrant, whilst the black one, which is g of x, sorry, which is f of x, is in the third quadrant. So the y values for the green, they are what? Positive, whilst the y values for the black one, they are negative. Therefore, if you multiply those y values, you get what? Negative answer, or you get 0. Right? Then we are now in the first quadrant now. Right? First quadrant, both are what? Positive. We don't want them. Then suddenly, the graph of f of x becomes negative. Negative, 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 whilst the graph of g is positive, so negative up to somewhere there, which is this point here. Right, so we need to find the x-intercept at that point, which is close to 180 degrees. Fortunately, because we have got the computer, so that's j. So from 90 degrees to j, okay, 90 degrees to what? To j. So j is 171. Okay, 171. So the answer is going to be, or from 90 degrees all the way up to 171. Okay, you following? Huh? Right? Then we have another interval. No, because the green one suddenly becomes negative, whilst the black one is what? Negative. So we only have two solutions. And you can test those solutions. You can test them. But unfortunately, we don't have time to test them. But please, if you have got time, just on the internet, download this application. It can help you a lot. Right, any question? Right, I want you to be aware that I found the values where you got the critical points using the computer. In your case, you just have to estimate them. Okay? And we'll give you a room for what? For error based on your graph. Are you following? But you can't use the general solution to find the answers for this one. You can't. But for the first one, you can. Because f of x is greater than or equal to g of x means there's a point of intersection that you have to consider there, and which you can determine by using the general solution. Any question? I'm not going to talk about area sine and cosine rule, but I want you to be aware that there is no proof on area sine and cosine rule in your paper, no area rule in the paper. It's only sine and cosine rules. Okay, and it's mainly the use of the formula. Okay, you just need to know your formula. It's a over sine A or b over sine b. You have your diagram, identify your length of sides and the angles, then you substitute, you simplify, you get your answer. It's the same thing for the cosine rule. A squared is equal to b squared plus c squared minus 2bc cosine of A. Given the diagram, identify your values of A, B, C, and the angle. And then you substitute, you simplify, that's it. It's very easy. Okay, we didn't do 2D and 3D problems on cosine and sine rule. So the question which is there is very straightforward. You should be able to score marks.
So what is something like this?
Yeah, but that's a 2D problem. This one is more complex than what's in your paper.
So you working on
It won't be like that. But if you can do that question, then the one within the paper, you should be okay. Okay, so let me talk about the geometry now until the end. Okay, now your geometry, you have got numerical problems whereby you need to find the sizes of angles. So here you are given this diagram, right? The question says calculate giving reason the size of each of the following angles, right? Let's start with the first one, angle A. Now, when you're answering geometry questions, please be aware that your geometry theorems, they are classified into 3 groups. We have the center theorems, right? Center theorems. Line from the center, from the center of the circle or passing through the center of the circle is perpendicular to the chord, and the converse. Line from the center through midpoint of chord, right? Then theorem 2, generally, depending on how you were taught, angle at the center is 2 times angle at the circumference. Also, angle in the same circle, it's a center theorem. Angles in the same segment, that's also a center theorem. So you have your center theorems. Then you've got your cyclic quad theorem. Right? Cyclic quad. Opposite angles of the cyclic quad are supplementary, that is the angle of 180. Exterior angle of the cyclic quad is equal to an interior opposite angle. You have to know that. Right? Then your tangent theorems. Okay, the tangent theorems, tangents drawn from the common point are equal. Tan chord theorem that's the most important, the tan chord theorem. You have to know the tan chord theorem. Okay? Tan chord theorem, you also need to know that a tangent and a radius at the point of contact are perpendicular to each other. Right? Sometimes, but it's not important for your paper, equal chords subtend equal angles at the center and at the circumference. You might need that, but it's not important for your paper. But you need to know that your theorems are only 3 groups. It's not that difficult. Then you need to know your proofs of theorems. Theorem 1, the proof you need to know. Theorem 2, angle at the center is equal to 2 times angle at the circumference. Your cyclic quad theorems, opposite angles of the cyclic quad are supplementary, you have to know that. And the famous tan chord theorem. So there are 4 theorems that you have to know their proofs. One of them is there on Monday. One of the 4. Okay? They are one of the 4. I can't say which one. You, maybe you can guess only one. Most likely. What?
Education, every guess.
Well, it's theorem one, line from center perpendicular to a chord bisects the chord. Right? That's examinable. Angle at the center is equal to 2 times angle at the circumference. Then opposite angles of the cyclic quad, tan chord here. One of those four that I mentioned is part of the. No. You go home and you know which one. Right. If you can manage to guess that, that's up to you, but there are four. Next year in grade 12, there are two, total 6 when you write metric. Right? One of them comes always. One of them comes always. All right?
And that one is a time for
Yeah. I don't know. All right. Okay. So, I've given you a bit of some background here regarding geometry. Right. So let's answer these questions. When you are answering geometry questions, please, I have come to a conclusion that geometry is not as difficult as what people consider it to be. Right? Have the right attitude in the head, your perception in the head is very important. Right? Don't surround yourself with people who say geometry is very hard. Once you do that, it affects you. Because the moment you see a diagram in a paper, your brain shuts down and it tells you, no, it's very complex, you can't do it. You need to have a strategy as to how you approach a question. First, know your theorems, right? Every theorem corresponds to a specific diagram when you are given a question. So you need to know your theorems first. Then there are keywords that you must look for when you are answering questions. Questions like diameter, right? Radius, tangent, parallel lines. When you see this, you must remember something about it, right? You have chords, right? What else? The center. These are keywords that you find in questions, cyclic quad. They are keywords that you find when you're answering any geometry question. Right? So if you see a question talking about the diameter, mentioning the diameter, what do you know about the diameter? Right? Radius. What do you know about the radius? How many theorems do you know about the radius? Tangent. Obviously, the most common one, tan chord theorem. Right? Parallel lines means co-interior alternate corresponding. That's what it means. Chords. Now, with the chords, you might need to apply your theorem 2, that is angle at the center is 2 times angle on the circumference. Then center, it gives you a clue whether are you going to apply a center theorem or not. Right? Cyclic part, it means identify 4 points inside the circle, or rather, that are on the circumference. Those 4 points, they've got theorems related to them. So we must identify. Right? So let's start with A now. The question says AEB is 55, C is 100, F is 35 degrees. Right? We have got a center, obviously, we have got chords DE and CD. Right? So, this is very easy. Angle A is this one here. Okay? We have a center, and it means BE is a diameter. Okay? BE is a what? It's a diameter. An angle subtended by a diameter at the circumference is equal to 90 degrees. So angle A is going to be 90 degrees. Your reason angle at center, sorry, angle in a semicircle, rather. It's angle in a semicircle, angle in a semicircle. Okay. Please, not angles in a semicircle. There are not many, it's one. So it's angle in a semicircle. Okay? Not angles in a semicircle, please. Then E1 is this angle here. Okay? Now, always try to identify cyclic quads. The moment you see a shape which looks like this, ask yourself, do I have a cyclic quad? Well, this question is there. B, C, D, E. It's a cyclic quad. So angle E1 plus angle C, they give you 180. Okay? So here I can say E1 is going to give out 180 degrees minus 100 degrees. The reason there is going to be opposite angles of cyclic pi. Please don't have to write all long stories here. Just write opposite angles of cyclic pi. That's all. So angle E1 is going to be 80 degrees. Okay? It's not very difficult. And don't be scared by the diagram, please. Okay? Don't be scared by the diagram. So we found angle A, angle E, now we find angle D1. Let me see if I've got, okay, I've got, so I'm going to do D1 in. So D1, right? D1 is this angle here. It's that angle there. It's an exterior angle of a what? Cyclic part. Okay? I would do it using the exterior angle of the cyclic part. That would be the easiest. So D1 is equal to angle B2. Right? So that would be exterior angle of cyclic part. Okay? Now the question now is, what is the size of B2? Okay? Now to get B2, we have got a triangle. I hope you can see a triangle BCF. So I can calculate B2 using in triangle BCF. So I would say in triangle BCF, okay, in triangle BCF, B2 is equal to 180 minus 35 degrees plus 100 degrees. My reason, sum of angles in a triangle. Okay? So B2 is going to be 180 degrees minus 135, and that will give you 45. 45 degrees. Right? Therefore, G1 is going to be 45 degrees. Then we are done. Right? Yes? Find E2. You're saying E2, this angle, is equal to? Yes, yes, yes. So it's equal to that. Yeah, it's fine. It's fine. Do you want to say? She's saying E2 is an exterior angle of a cyclic part, so it's equivalent to angle C. So this angle is 100 plus 35, you get 135. 135 from 180, you get what? 45. So you also answer the question based on what you see. Okay? But it's not that complicated. Have a positive attitude, then you should be fine. Huh? Are you okay? Are you following it? Alright. Okay, then prove, giving reason that AB is parallel to CF. Now, in grade 11, for you to prove that two lines are parallel, you only have two, I would say two methods. The first one is to use your knowledge of alternate corresponding co-interior angles. That's the first method, right? Then, the second method is to use the midpoint theorem. In this diagram here, we can't use the midpoint theorem. So it means I have to add two angles If they add up to 180, then I can say therefore those two lines are parallel. My reason, co-interior angles supplementary. Or I have to prove that they are alternate angles. If the angles are alternate, they are equal, they are corresponding, they are also equal. But in my case, I'll use co-interior. Right? I don't know how, if anyone did the question, how you did it, but I would do it this way. This is the easiest way. I'll add this angle and that angle. If they give me 180, then I'm done with the question. Okay, I'm not complicated. If you want to do alternate, if you can do that, that's fine. Maybe you might need to share with us how you do alternate. But I'll do it forward, continue. So I know that B2 is 45. So I'm going to use what? Co-interior. Right? So this is how I'm going to do it based on co-interior angles. I need to find the size of B1. Right? I need to find the size of B1. So angle of B1 is equal to 180 degrees minus 90 degrees plus 55. Okay, where am I getting that from? If you look at triangle ABE, if I take this angle plus the 90, I'll get what? B1. You follow that? So this will be sum of angles in a triangle. Right? Then this will give me 180 minus 145, and that will give me 35.
So the number says B1 is equal to A.
Okay? You said B1 is what? Okay. So after finding this B1, this B1 is what? Yeah. Okay. I see now. In my case, I didn't see what she just said. I saw that if I can add this angle and that angle, if I get 180, then I'm done with the proof. Yes? Okay, be very careful there. There are many angles around point E. So you need to be very specific which angle. Okay? So if you add B1 plus B2 plus C2, so that will be angle C, right? So that will be angle C. This gives us, yeah, I'll say equal to, right? This will be equal to 35 plus 55, or 45 rather. Are you following here? 45 plus 100, and that gives us what? 180. Therefore, AB is parallel to CF. My reason here is co-interior angles supplementary. So SUPP. Or you can say co-interior angles add up to what? 180.
And about the alternate angles, we have to say alternate angles equal.
Yes, alternate angles equal. If it's corresponding, you say corresponding angles equal. Okay? That's it. Are you following that? So don't be scared. Just know your basics. Right. Next question. Are you okay? Yeah. Don't be scared. Right. Then theorem one. So when you see a diagram like this, line from center perpendicular to chord, line from center through midpoint of what? Chord. Right. So you can read the whole story here. OC is equal to 2CD. So OC is equal to 2CD, which means CD is half of, OC is 2CD. Okay. Don't worry about the numbers there. Then B is 30 centimeters. So BE is 30. Now, this diagram here, I don't like it because AOCD is perpendicular to BE. So I think they should have indicated there. That they are perpendicular on the diagram. Of course, they stated it there. but on the diagram it was supposed to be in here. Right. Now, BC, to calculate BC, 9.1, BC, right, is equal to half of BE. And the reason here will be line from center perpendicular to chord. That's your reason. Theorem 1. Okay? Once you see the right angle on the diagram, it means you're supposed to use theorem 1. If the right angle is not there, and you are told that BC is equal to CE, that's the converse line from center to midpoint of chord. Are you following? Yes? No, it's BE. So it's my handwriting. Let me rewrite it nicely. This is BE. Right? So BC is going to be half of 30. Okay, 30 is not an angle. Right? So that gives you 15 centimeters. Okay? So it's 2 marks. So the first mark will be for the statement and the reason, the second mark will be for the answer. Okay? If your reasoning is not correct there, you get 1 out of 2 for the answer only. Right? Then 9.2 says if CD is equal to A units, right? So CD is equal to A, let's put that on the diagram. So CD is equal to A units, determine OC, okay, in terms of A. Now, if you look at this ratio here, that's the one we are going to use there. Right, so 9.2, we are told that OC is equal to 2CD. It's 1 mark, remember. So, if you want to find OC, means OC is going to be 2 times A. You see how easy it is? Sometimes the question will look like it's very scary, but it's so easy. It just requires basic knowledge because OC is equal to 2CD, but CD is equal to A. Therefore, OC is going to be equal to what? To 2A. Okay? So let's put that 2A on the diagram. So OC is going to be 2A. Which means our radius is going to be 3A. Are you following? Right? So let's move on to the next question. You have to know your theorem 1, by the way. I put a nice question there. Yeah, I put a nice question. Okay? The 9.3 OB in terms of A. Now OB is from here to there. Alright, if I were to ask you a question, how many red dyes do we have there? How many red dyes do we have on the diagram?
4.
There are 4. Thank you. We have OD, OE, OB, and OA. How many do you see? There are 4. You see, some of them they won't be written they won't be drawn on the diagram. But you should know that if there's a center here, there's a point on the circumference, that's a what? That's a radius. So 9.3 OB is equal to OD. They are radii, right? So you write your reason radii. Okay? So you're following that. But what is OD? So OB is going to be 2A plus A, and this gives me 3A. Okay? Are you following? Right. Make sure you know what I just did here. And 9.4, the value of A. Right? The value of A. Now, this is interesting. To find the value of A, that's a high order question. Right? So you may have to create a triangle, a right angle triangle. So in my case, I'm going to use triangle. This is point OCE. Okay? Are you following what I'm doing? To calculate the value of A, you have to identify a right angle triangle and use the theorem of what? Pythagoras. Don't be scared. Right? So, 9.4 I'll say in triangle OCE, alright? The good thing is I now know my dimension, so I can write this as OE squared is equal to OC squared plus CE squared. Please don't forget to write Pythagoras because you might get a mark there. Okay? You're following there. Then OE, okay, that's 3A. So this will be 3A squared, like that. Please write it down like 3A all squared. Then OC, that's 2A, put it in brackets like this. Okay? Are you following that? Plus CE. Now CE is 15 squared. Then everything else is algebra. So this is 9A squared is equal to 4A squared plus 225. Okay, so I'll get 5A squared is equal to 225. Okay, then we divide both sides by 5, so we get A squared equal to 225 divided by 5, that's 4. Well, remember 2, I'll get 45. Okay, so A is going to be the square root of 45, which is the same as 9 times 5, so that will be 3 square root of 5 units. Okay, but in this case, it's centimeters.
What is leave a circle? So
Okay.
would we leave it then as 345?
Leave your answer in similitude. Okay. I don't like the language there. Leave your answer in set form, not simplified. Alright, the simplified set form means you have to leave it after rationalizing. Okay, so I'm rationalizing. Okay, so the answer will be 3 square root of 5 centimeters. Alright? I hope you saw what I did here. Okay. Okay? Any question? Any question? So on Monday, just to give you a hint, right? If you see a center here and there are points on the circumference, just join that center and the point on the circumference and count the number of lines. Those will be what? The number of radii. Right? So that's easy. Okay? Can I move on? So, okay. So when I put the question, let's see if I can manage to do one more before we go. Okay, so argue, I'm going to add that on the diagram.